Hello, everybody. Good afternoon. I am Donatella Ponziani, ESA Downstream Gateway Officer, and I have the pleasure to welcome you to the third episode of our series of webinar, Space for Twin City, dedicated today to urban planning. I will hand over to my colleague Javier Ventura Traveset in a few minutes. Javier is working since more than 30 years at ESA, in which he has been covering several roles in multiple space programs, satellite communication, health observation, scientific programs, microgravity, technology transfer, and notably satellite navigation. He is currently in charge of coordinating GNSS scientific activities in ESA, where he is the head of navigation, science, and office. Javier, the floor is yours. Welcome.
Okay. Thank you very much, Donatella. Very good afternoon. A great pleasure for me, an honor to be invited to moderate this seminar today. I would like to welcome all our ESA Web TV audience and certainly the participants of the seminar this afternoon. Seminar Space for Twin Cities and Urban Planning, really interesting. We will have representative from Municipality of Milan. We will have Piero Pelicaro. I think he will join in some minutes. He's the Chief Resilience Officer of the Municipality of Milan. We will have also from Milan, Andrea Liscioni. He's the Director of Integrated Water Service Division. Good afternoon, Andrea. You are there, I believe. Okay.
Good afternoon to everybody.
Hi. Very good. Thank you, Andrea. Thank you for joining with us. We have then from the Municipality of Baia Mare in Romania, we have Sorin Pop. Good afternoon, Sorin. Pop.
Good afternoon, very nice to have you here. Good afternoon, very nice to have you here.
Thank you, Sorin, for joining. And then we have two ESA colleagues. And then we have two ESA colleagues from the Earth Observation Directorate. Zoltan Bartalis. Good afternoon, Zoltan.
Good afternoon. Hello, everyone.
Hello, Zoltan. And then last but certainly not least, from the Telecommunication and Integrated Applications Directorate, my colleague Beatrice Barresi. Hello, good afternoon, Beatrice.
Good afternoon. Thank you for inviting me. Thanks a lot.
Thank you, Beatrice. So we will have a total of 5 interventions. While waiting for Piero, I think we will start with Andrea Liscioni. Andrea is the Director of Milan Integrated Water Services at the Municipality of Milan. And Andrea, you are actually managing the entire water cycle services in Milan. I understand this includes planning, design, implementation of investment, so such an important thing like the management of drinking and water, sewage services, and also the final purification plants. Andrea worked before as the head of the purification and sewerage service also in Tuscany and Lazio. And he was also the director of a mining plant in Italy and abroad. So a very extensive professional experience in the management of water services, such a, again, important service for all of us in the cities. So Andrea, could you please provide us with an overview of what is the SMART approach? What is the use of technology for the structural monitoring of the Milan sewage network?
Yes, thanks, Javier. I'd like to present our specific experience using a satellite application here in Milan. Our target, our challenge is to prevent risk of surface collapse or subsidence phenomena related to our sewage network. In this slide, you can see the whole wastewater drainage system here in Milan. It's a sewerage system with a total length of about 2,000 kilometers of extension. So it's very important for us control and detect every movement of every surface movement over this underground structure. We have basically three inspection and detection methods nowadays. The first one is human inspection directly inside the conducts. This kind of inspection is dangerous and is characterized by low productivity because at maximum we can cover about 50 kilometers for years. So we can check the same place about every 30 years. A second method, we could use ground instruments like IoT instruments, for example, and now we use this kind of instrument, but for cover the whole extension of our net, we need thousands of sensors. And the third method is using a satellite system, so space service system. With the satellite system, in the case of Milan, we use Copernicus Sentinel-1 SAR data. We can cover the whole surface over our infrastructure. We can use a high frequency of acquisition and refresh of the data because every month we have a new image, a new passage of the satellite over the city, and so I can refresh the data and the situation of the surface over my sewerage system. And obviously, respect to the first one and the second one system, the low cost associated with this methodology. If we see the next slide, please. I present the first example of this application. This example shows a red point automatically detected by the system, associated with this red point you can see on the map. There is a subsidence phenomena during the time. You can see the graph. And this kind of phenomena is related, in this case, you can see the photo on the right, is related at a specific damage at the top of the conduct. So the system give me an alert with this red point. I can send my people inside my infrastructure and check the health of this infrastructure. In this case, I find an hazard for surface and the road stability associated with this damage at the top of my sewage conduct. In the next slide, you can see another damage, in this case associated with an unsaid water channel abandoned. So with the same system, I can find an unsaid water canal not used at the moment, and I can find also in this case a high hazard for the surface stability and for the people that use this road. So this system run with results for the municipality of Milan and allow us to plan our activity in terms of investment, in terms of manage of this infrastructure, water infrastructure.
Okay. So that's thank you very much, Andrea. That's really very interesting and appreciated. It's something when you live in a city that you don't see who is taking care of those services and how our technology is really helping for the monitoring. Highly appreciated. We remain actually in Milan. We will have now the Chief Resilient Officer in the municipality of Milan, that's Piero Pelicaro. So Piero is already 10 years working in climate change policies and the urban resilience planning. He's actually the Chief Resilience Officer and the city lead of the Horizon 2020 Lighthouse Project Sharing Cities, which is done at the municipality of Milan. He's actually an advisor as well of the Italian Ministry of Environment, Land and Sea, notably on urban adaptation policy to climate change. And I understand, Piero, that you co-founded also Climalia, a company specialized in providing climate services consultancy in Italy. So, Piero, we would like really to know, you are working in the municipality of Milan. You can give us maybe orally an overview of the urban planning on the municipality of Milan. What is the urban planning project in this moment, Piero?
Thank you, Javier, and thanks for giving us the opportunity to share with you all our experience on this. I mean, I will start from a point that was important and about the urban planning. Thanks to the collaboration with the 100 Resilient Cities Network, and thanks with the collaboration with the Bloomberg Associate and the National Observatory of Athens, a couple of years ago, we started mapping the surface temperature of the city. So we started looking, and we developed a layer or map that was giving us the surface temperature of the city. That was useful for us for two purposes: to communicate to the community how climate change is impacting on the soil, how it is impacting on the life and everyday life. And on the other end, is supporting our colleagues at the urban planning department to identify which is the potential areas where we should invest more in terms of greening, in terms of canopy, in terms of blue infrastructure. So it leads us and help us to identify where also an added value. Together with Andrea, we have started working, identifying where we should place the new water house, so where we can distribute water, public water and fresh water to the community based on the fact when there is the heat island effect. So this kind of layer of information about climatic data on the ground was used, adopted by our GIS system, but on the other end, it became part of our interoperability platform of the cities, because internally with the staff, with the colleagues at the digital agenda department, we are implementing an interoperability platform where we are integrating all the different data layer and information that the city has available, because that is now becoming more and more important for different purposes. From a resilience point of view and from the urban planning point of view, the impact of climate change are differently even within sites of a city. So we have a northern part of the city that is different from the southern part of the city. So going to the direction of developing a microclimatic urban planning approach, so planning specifically for every kind of district based on the environmental and climatic condition, it leads us to a need to have more and more data layer, data information, data integration in the process. Because one of the other tools we are developing for the urban planning, integrating data, it's together with ESRI, our GIS provider, ARUP, that is a strategic partner of the city for the 100 Resilient Cities program. We are mapping all the potential, all the roof of the city, and to give back to the city and the community what they can do with their roof. They can do a solar roof, they can do a green roof, a blue roof collecting the water, a gray roof, a mixed one. So as a tool to communicate. On the other, it's also give us to colleagues of the technical department to better planning and better design all the retrofitting and all the future development of the energy transition in the future. So this integration of data using satellite data we are collecting also lead us to another topics that it's important, is how we integrate all the citizen science approach. So all the data coming from the community. And thanks to our open data deputy mayor, we are now creating a new working group and a network of data collecting by the community and how we should integrate and using and validate. So all these kind of layers are becoming more and more important for the city of Milan. And what is, I think it's more important that all this integration and the integrated platform has been developed by the city itself. So with the internal capability that help us to be more leading the process internally than outside. So I think I give you shortly what we are now doing in terms of urban planning and data using satellite and the sensor.
Okay, thank you, Piero. Actually, how many inhabitants are today in the municipality of Milan, Piero, in this moment?
Well, at this moment, it's a good question in the sense that at this moment with the light lockdown, we really don't know. But normally, previous the COVID, we have 1.4 million inhabitants. But on the daily basis, we get between 800,000 up to 1 million people join the city every day, so the commuters. So the city itself, it's 1.4. The metropolitan area is 3.2 million. Plus 1 million of people coming to Milan every day.
So it's a very large city indeed in Europe. And how many people is working in urban planning in this directorate?
In the Department of Urban Planning, we have around 350 people working in the urban planning department with different services. Plus, there is other 100 people working at the environmental transition department that are also in charge of some element of the urban planning planning.
Very good. So you consider Milan really is a reference today in Europe in terms of urban planning. Would you say that?
Well, we are looking. Well, we are proud of what we are doing, but I think there is an excellent exchange with the other European cities, starting from Paris, Barcelona, Berlin, and London. So we are doing our best for our community. Hopefully, we can help also the other to be inspired.
Thank you very much, Piero. Very, very interesting. So we moved from Italy to Romania. We will introduce the third speaker. Is Sorin Pop. Sorin actually working in the municipality of Baia Mare in Romania. Sorin is an entrepreneur. Sorin is an entrepreneur. He's really a project coordinator and strategic planning expert. Has spent around 10 years implementing R&D activities and innovation projects in cooperation with several municipalities. Romania, I think I have a list of projects where you have been working, Green Top, Familia, all related to the use of Earth observation data in urban planning. I think here information and communication expert in urban development strategy. You have been delivered solutions for smart cities like in Alba County, like Baia Mare, like Bistreet, in all these cases, including Earth observation functionality for green areas management. Sorin, you have a PhD on the topic of open innovation for smart communities. So we would like then to hear Sorin's insights on the smart regenerative ecosystems in the case of the municipality of Baia Mare. The floor is yours.
Thank you, and thank you for the invite. It's my pleasure today to bring you an urban innovative action that the city of Baia Mare is implementing. It's called SPIRE, post-industrial regenerative. As Baia Mare is about smaller than Milan, I would like on the next slide to show what the city is about. In the 1200th century, we were a mining city, and right after that, we had one of the most important means in the Austrian Empire. This led to an increase of mining materials like lead, gold, silver, and so on. And in the last part of the millennia, we started building industrial facilities. This has led to huge and the water and the air. We even have one of the tallest towers built in the late 80s. It's about 350 meters. But after the collapse of the mining sector, after the collapse of the mining sector in Romania, the city began having some trouble. Starting in the 2000, what we call the most terrible biological accident after Chernobyl, which was the biomass cyanide spill. We started considering to become a green capital of Romania. Starting from these experiences, we decided to create a new project, which is the SPIRE project. Next slide will show you the ecosystem that we're trying to create. So one of the first things is that we started building an immaterial local environmental utility. This is a local coin based on blockchain, which aims to reward people for actions that take care of the environment or restore very polluted land. Based on this local coin, we're trying to build an ecosystem, and around it a makerspace and a hub where we want to stimulate entrepreneurs in the green economy and people with very creative or innovative ideas. Based on what the SPIRE Hub experience will provide, we identified 7.5 hectares of heavily polluted land inside the city limits, which become our, let's say, playground of using plants in order to restore and reuse the soil. Obviously, we have to monitor this process, and we're doing this by combining Earth observation data with some very simple indexes and ground truth pollution measurements in plants and in the soil. Just to get people involved, we've created a program that will reward people for walking to or for taking their bikes, and we would track them using their mobile phones if they install unallowed application. With respect to that, the data from the application will be used for smart mobility data so that we can adapt the tracks of bike lanes and pedestrian areas. All the data goes back into building experience and finding a way to recover more polluted land. Of course, the phytoremediation sites will produce biomass, which is wood or other plant material that we want to use in our makerspace in participation with people in order to create either new material or energy or maybe something new that we didn't think about, but people will create. And on the next slide, you will be able to see that what we decided is to use very simple data like vegetation indexes or PSRI. So, and of course, the soil analysis data so that we can monitor the evolution. And also we want to use AI algorithms to predict what would happen if we carry on with some activities. We want to assess both the biomass production, both from satellite imagery and from the actual measurements of how many tons of biomass we're producing. And we want to replicate everything throughout the metropolitan area, where there's an estimation of more than 600 hectares of heavily polluted land, where cadmium and lead concentrations are 7 to 9 times more than the maximum alert limit allowed in Europe. On the next slide, you will see another experiment that we carried out. We measured plant stress during different periods, and we used an artificial intelligence algorithm to simulate what would happen after a while if we only leave there the spontaneous vegetation that we currently have. And we found out that the stress level in plants remains the same, and unless we act now on phytoremediation, we will not have any spectacular results. So this is why we have decided in the city that we need to use something innovative to measure everything and to provide replication means. A few years back, we used also satellite data to bring all the trees in the city into one database, into our GIS system. This was very helpful because it helped us save a lot on costs. Initially, in the city, this was performed by using topographers and biologists who are just measuring the trees manually. So this was one of the most efficient ways to reduce costs and keep up-to-date system of tracking green areas. On the next slide, I would basically like to thank the Urban 2020 Association and Indecosoft, which is the technical supporting partner of the Spire project, because without their involvement, neither the urban planning and the involvement of the community and nor the technical solutions would have been at the city's disposal, as our city doesn't really have a lot of expertise neither in GIS or Earth observation. So I would like to kindly thank everybody for participating and for following this presentation. And I hope we will represent a good practice example across Europe and that our expertise will be repeated in other cities. Thank you.
Okay, thanks very much, Sorin. Very interesting, Sorin. So let me ask you one thing, Sorin, before we move to the next. The data that you use for Earth observation is important that it's updated on real time, or you can wait for months? Is more the historical data? Do you use everything? Which is the actual data that you are exploiting in your planning?
So for the Spire project, we are using Copernicus data, and we have taken pretty much every single image that Copernicus Sentinel-2 has on Baia and is not clouded. In terms of green areas monitoring, we have used commercial data, and we use it. We are taking one set of images every year, basically in the month May or June, when the vegetation is at its foremost. So this is the data that we're using right now.
And you are combining Earth observation data with local data, which from local sensors as well?
For the Spire project, there are no sensors yet. We have a partner, which is the University of Agricultural Science, that actually goes into the field and takes measurements. They process it in a lab, and they provide us with the data that we are comparing to what Earth observation gives us.
Okay, so it allows to calibrate and excellent. So thank you very much, Sorin. Really very interesting. I'm very proud also of contributing from ESA actually to help on this way. And actually, I have now the next speaker, which is directly working in the Earth Observation Directorate. This is Zoltan Bartalis. Zoltan is working in ESA in Esrin near Frascati in Rome. He's working for the Earth Observation Directorate as an application engineer. He focused on growing prospects of satellite Earth observation data for applications, especially in a sustainable way for day-to-day activities. I think the thematically of Zoltan is particularly of interest is the urban development. So that's why he is here. Energy and natural resources. Zoltan has a master's degree in space engineering from the Luleå University of Technology in Sweden, and he has a PhD in satellite remote sensing from the Vienna University of Technology in Austria. So we welcome Zoltan, and let me ask you, Zoltan, what is the current use of Earth observation data from our Copernicus and other satellites in the European urban planning landscape? If you can give us some insight into this question, Zoltan.
Yes, of course. Thank you, Javier. I'm very happy to give you a very brief overview of what's possible in terms of satellite Earth observation in urban areas. We work quite a lot in this area since many years back with all kinds of different stakeholders, and urban planning itself is part of this process that we can support with satellite analysis. So before giving you a few examples, just an overview of our present and future Earth observation missions at ESA. We have now 16 satellites in orbit. We are developing about 25 more, and a dozen more are under development. This is in the planning. So this is by far the largest number that we've ever had. And on the right side of this graphic, you see a band containing the meteorological missions, which is a branch of Earth observation that is so mature in Europe and everywhere else that we've handed it over to a dedicated organization called EUMETSAT for operating this kind of satellites. On the leftmost, so innermost band, we can see our truly scientific missions called the Earth Explorers, which address questions of science, critical and specific issues raised by the science community, the geoscience community. And in the middle, we see the what is actually now the Copernicus program, the so-called Sentinel satellites, which are the workhorses of operational Earth observation in Europe. And this program is financed by the European Commission, and we design, launch, and operate these on their behalf. And Copernicus is a major contribution to the study of the Earth's environment. It's basically the most advanced Earth observation system that we've had globally, I would say, providing far larger volumes of data than we ever had before. All of this data is, of course, free and open. And in Europe, we've had a deliberate investment not only in having sensors in space, but also founding a strong EO service sector with a lot of research institutions and SMEs doing value adding using all the satellite data, so we can obtain information and solutions to issues like in the urban environment to serve the stakeholder communities. So let's move quickly to urban applications. Just a few examples because the time is limited, but this will hopefully give you a good taste of what's possible only by scratching the surface. I took this slide from our recently conducted and concluded project called EO4SD Urban, where we continued our support to international development agencies, demonstrating urban applications based on Earth observation data in the context of these institutions' projects in developing countries. This is the most common types of EO products on one slide, from baseline products based on land use and land cover to higher level and more analytical products, for example, urban extent, imperviousness, detailed building footprints and heights, detecting transport infrastructures and informal settlements, combining population data that is not from satellites with the satellite-based land use to obtain more detailed population distributions, and also a series of risk-related products like floods and landslide risk, but also terrain motion, so subsidence through microwave radar missions and instruments. So most of these products can be derived at various resolutions, and we can, of course, the big asset is that we can study temporal changes of the environment by for many of these parameters by looking back in the archives of satellite data. And what's a better example? Next slide, please. Then looking at the temporal changes, the historical urbanization of built-up extent in one of the most important urbanized areas in the world, in Shanghai, the greater Shanghai area. So with the vast archives of satellite data, we can go back in time and really make evident the environmental changes that take place. This image is about 200 kilometers across, so I think this is a stunning example of how our built-up environment has been changing. And each color shows the built-up area extent in one specific year. So starting from the core areas and spreading towards the periphery. Another example that is specific to urban planning that we are talking about today. Here we supported a World Bank study in Tanzania in 7 secondary cities, where the big question was whether the urban master plans that they had in place, if they were achieving their goals. And we helped study the temporal evolution of those cities over a decade, from 2005, shown in this image in the example of a part of the city of Arusha, until 2015, which is the next slide. I don't know, I cannot see my slides, so yes, I think now we can see the next slide in 2015. Thank you. So you can clearly see that there's been rapid urbanization, and the next slide will show you it's a figure actually taken from the World Bank report that came out of this. It compares on the left side the original 1985 master plan. In the middle, you have the actual land use from satellites that we derived 30 years after, and on the right side, you see the diversion or the departure of the actual state of the land use at the moment, the departure from the original plan. This is, of course, an important instrument to make a point to the governments and influence the way that the investments should go. Another example, very quickly, just to show you that these land use-based products can be derived at more detail and also for very specific thematic layers, in this case related to urban health and quality of life. We see here the distribution and evolution of urban green areas in the city of Bhopal in India over 12 years. You can see clearly the permanent urban green areas, but also the losses and the new areas of greenness in the city. And the last example I wanted to show you today is relating to the useful information that we can gather on natural hazards related analysis. So this area here in Saint Louis in Senegal shows you the flood hazard and the flood risk maps derived after having looked at a long series of imagery, both in optical and the radar domain. And this knowledge, of course, can be extremely useful when looking at the spatial expansion directions of a city and the planning of working with master plans to control this expansion and to make sure that this expansion doesn't go over terrain where there could be natural hazards or natural hazard events. Okay, thank you very much. That was it from me.
Okay, so thank you very much, Zoltan. Very, very interesting and nice. You know, we always say, that we have the most ambitious Earth observation program in the world. Through Copernicus and the Explorers and the Meteorology program, but certainly Copernicus is the most ambitious in terms of data which is available free. That's really great. Today, I understand, Zoltan, actually around 25% of the ESA budget is dedicated to Earth observation. Is that the correct figure, Zoltan?
Yes, Earth observation activities are the largest chunk of our activities in terms of budget.
Yes, so you're much younger than me, but when I started at ESA 30 years ago, there was not even an Earth Observation Directorate. It was really a marginal thing, and now today is the most interesting program, and it is simply natural, and we see the tremendous benefits. By the way, Zoltan, we launched the last Sentinel last Saturday, it was Sentinel 6A. Any news? How is the satellite going?
I don't have any news about that, but I know that the launch was very good, and I really look forward to new products on ocean altimetry, helping us to understand, together with all the other instruments that are already flying, to get a better picture of what's going on.
Yes, Sentinel-6 will monitor especially the topography of the oceans in that case and the sea level, if I understand. But yeah, I assume they are now in the launch and early operational phase, and it will take a time for the in-orbit commissioning. But this is good. We have a fantastic dynamics in the Earth Observation Directorate. So we move now to the next speaker. Thank you again, Zoltan. We go to Beatrice Barresi. Beatrice is working in another of our applications directory, the telecommunication and integrated applications. She's downstream business applications engineer. Beatrice is working at ESA for already 10 years. She works in ESTEC in the Netherlands. I also work in ESTEC for a long time ago, and a fantastic ESA site. She works in the Space Solution Program. It's a program aiming to build economic sustainable services with the use of satellite data for the use of European citizens and the society at large. So Beatrice has been involved in as project manager in more than 50 services dealing with environmental precision farming, security and safety, and also in energy programs. Beatrice was working also before joining ESA for the space industry. She were in Thales Alenia Space, I understand, in Italy, and you were in that time working as system engineer and also as instrument for Earth observation satellite. So Beatrice holds a Master of Science in Telecommunication Engineering, and I think the background of Beatrice is really in remote sensing. So Beatrice, can you please tell us, what do you see the relation actually of space technologies and the green and sustainable infrastructure? How do you link the two, Beatrice?
Yes, so thank you, Javier, and I will try to answer your question by using a few slides to support the conversation. And before giving, let's say, an answer, I just want to briefly tell you what I do in ESA. As you were saying in the introduction, I work for a program which is called Space Solutions, and in a very short, the aim of the program is to help European industries in building sustainable services by using space data. For addressing the needs of different verticals, maritime, healthcare, transport, and so on and so forth. And in the next slide, you will see that sometimes, you can see the blue icons like the sky, the space asset. You have on the other side, on the right side, the verticals, which is the Earth. And sometimes to connect these two aspects, you need some more innovative technologies, some more powerful processing tools. So you will see that the majority of the services that the companies with our support develop not only use information coming from space, but also a lot of terrestrial and in general innovative technologies. I will give a first example of infrastructure which are quite important for our cities. In the next slide, you will see an example of service that can be used for monitoring our streets, our roads. We are all using roads every day with our private vehicles, with public transportation. And the number of high vehicles is really requiring a service which on one side helps the road operators to keep the traffic flowing, to avoid congestion, to avoid the traffic jam. But of course, at the same time, we want to reduce the likelihood of having accidents. So meaning we want to look after the safety of the citizens. This solution that has been developed by, it's called Equant by a British company called Valeran, basically use this stud, which is the sensor that you see in this picture. And the stud is a collection of different sensors. So within this sensor, you see a light, you have a thermometer, you have a magnetometer, you have a microphone, and all these information are then used for having information about the condition of the traffic on the road. And this, from the system architecture, so from this picture, you really see how nicely works the integration between the space component and the terrestrial component. So the information collected by the stud are transmitted by either satellite communication or by terrestrial coverage to a cloud center. And the cloud center is really the brain, the intelligent part of the traffic monitoring system, because it's where an artificial intelligence algorithm is applied to understand how the condition of the traffic is going to evolve. So, for instance, if a number of vehicles are slowing down, or they are going towards the hard shoulder, this could be an indication that there is congestion coming, that or maybe a vehicle has some damage, so there is a broke down vehicle on the street. So the road operator can take measures, for instance, closing a lane before there is really a traffic jam. In the next example, you will see then how this concept about managing the infrastructure of our city can be brought one level higher, and that's what a digital twin does. You can build a digital twin of our planet, of the Earth. You can build a digital twin of a forest, and you can also build a digital twin of a city. And the power of this tool is that it can be used for descriptive purposes, so it can be used to monitor the current situation, so to see what is the effect of past policies. It can be used for prediction, so really to see how the system is going to evolve in the future. But mostly important, can be used for prescriptive purposes, meaning that can be used by decision makers to see what is the effect of their policies in the city. So how the different policy taken by the decision makers can impact, for instance, the quality of the air or the land cover or the noise and so on. But in order to achieve that, you have to combine different sources of data. So, for instance, you have to combine images taken from satellite, from drones, from terrestrial sensors. And in this way, you can have different mapping of interface according to the purpose. And the next slide highlights what, in my opinion, is really the key element of a digital twin. So by having that, in particular for our cities, for the municipalities, by using this tool, you can have a picture which freezes the situation as it is now. So you really see, you can have a tool which monitors the current condition of the city. But then, most importantly, you can do the what-if scenario. So, for instance, by using this tool that has been developed by a Finnish company, you can draw a polygon which basically simulates the construction of a new building. And by doing that, you can see what is the impact in the surrounding environment in terms of quality, energy, green space, and so forth. And again, that's a very powerful tool in the hands of the decision makers, because they can see almost, let's say, in real time, what is the impact of the different decision. In the next slide, I just want to say a few words about green building, because I think if we talk about sustainable development of our cities, if we think about green development, green future, we have really to think about this infrastructure. And the key aspect of the green building is that not only they have a neutral impact on the environment, meaning that they don't pollute the environment, but moreover, they can have a positive impact, meaning that, for instance, they can use renewable energies, renewable sources for generate energy and put it back in the grid system. But in order to do that, again, you need to have very precise information on the environment, on the weather, and also on the surrounding environment in which the building operates. So, for instance, you need to know with very accuracy, with a lot of information, what is the highest temperature under which the building is going to operate, because this value of temperature will cite the cooling system of the building. You need to know what is the minimum temperature of the building, because this will tell you what is the heating system. Or, for instance, you need to know what is the air quality condition or the humidity, because this will give indication about the ventilation. All these things, thanks to using the data from space and from terrestrial sensors, are possible. In the future, as space solutions, we are thinking to look at the urban green areas. So we want to have solutions which look at, for instance, parks, gardens, or ponds, and see what is the best way to also manage in an efficient way all this infrastructure, to make sure that the whole city as such is managed in a green way. And I just want to say the final words by showing in the next slide, you will see all the upcoming, let's say, initiatives that in Space Solutions are open or will be open in a short, let's say, scenario. I will not give details now, but in the last slide, you will see my contact details. So if any of the attendees has questions later on, you can get in touch with me and I'm happy to address them.
Thank you very much, Beatrice. What are the possibilities for this funding? Maybe very quickly. Yeah? So what ESA is offering actually?
Okay, depends on the activity. In this slide, there are different, let's say, initiatives showed, so different, let's say, funding scheme. There are competitive-based calls, so there will be 100% funded by ESA for developing feasibility studies. There are other activities that we want to do together with the companies. In that case, it will be a co-funded scheme that can be up to 80% funding received by ESA for SMEs, for instance.
Okay, very nice. I'm very pleased again of ESA is contributed in this direction. So thanks very much, Beatrice. It was really nice. I think I enjoy really the afternoon with the two examples of Milano and Bahia Mare, and then the two Zooms that you provided from Space Technologies. I would like maybe to finish the session in the next 5-7 minutes with a general reflection altogether. So this is the situation today. We see what we can do. We see what we are doing in the cities. But the things are going to improve in terms of technology. Certainly, we already listened to Zoltan. The plans of Earth observation are very ambitious. All the 25 missions already planned for the decade. Copernicus is going to improve the repeatability, the accuracy, the possibilities of the data. We have the Galileo program, where I have been working many years. Also, we are having the most performing, but we are going to provide a high accuracy service, 20 centimeter service. You can imagine we are working in the second generation. We are improving the connectivity with our industry and satellite communications, the new technologies which are integrated with those like 5G or artificial intelligence, Internet of Things. So the future looks like amazing, the possibilities that we can do. And I would like you to, if you can do an exercise of extrapolating a little bit, where do you see the future? And maybe I start with the cities. Piero, Andrea, maybe starting with you, Piero. What do you see will happen in, let's say, 5 to 10 years? Which things we can do better, Piero?
What we can do, it's better organized data, the information about technology. I mean, there is too much. I was in a previous discussion earlier today. We're always running in terms of data information. If you want to really use the data, I think we need not to looking for new data, but how to use better what we have at the moment. There's still not dashboard and platform information, desk returning. It's not really processing the decision-making process and the planning process in general in the cities. So my suggestion is not looking for new technology for new data, and somehow, we should keep it going because we need to stop everything. But we need to reflect more on usage because still there is a lot of people.
Okay, so you are insisting in the processing of these amazing quantities of data, and there is important to improve in these directions. That's what you are saying, Piero.
Yeah, exactly. So to not only collecting data, but also how we should process the data within decision-making process. Because at the end of the day, in the cities, a lot of the processes are still decided based on paper, based on conversation, not based on only with data. So it just make this display. When you go in a meeting, how many times you see a screen with an interactive data platform using maybe you or the others, but if you come in a city, that is not happening really. So that is what we should do next in the next 5 up to 10 years.
Okay. And let me ask then more specifically to Andrea, in the monitoring of the water services. What do you see like possible evolutions in the next 5-10 years linked to the technology possibilities? Andrea. I think Andrea, we cannot hear you. Maybe you are mute. Okay. Okay.
Okay,
So I
can
think,
you hear me now?
yes, now we hear you, Andrea. Yeah, I was asking.
Yeah. For water service application in urban area, like water leakage detection is very important task for us. We need now more optical spatial resolution. For example, for optical data like UV thermal band. Nowadays, to detect leakage in a road, in an urban context, we need to improve the spatial resolution, okay? And for the processing chain methodology, I'm agree with Piero. So we have to improve, we have to improve machine learning and deep learning, customized for the specific application.
Okay. Yes, I fully share what you say, Andrea. Thank you very much. And let me change city by Mare, for example, Sorin. If you could think in the technology possibilities in the coming 5-10 years, more data, more precision navigation services, the combination with 5G, IoT, the artificial intelligence, how do you see the evolution in the planning in your city in Bahia Mare?
Well, it's obvious that everything that you've already said will happen. We will have more and more data, better quality, better accuracy, better everything. But in my view, what we need to have also is a little bit of human-centered Earth observation. Not very long ago, and even this at the beginning of this conversation, we were talking about citizen input and people reporting problems or whatever in our GIS solutions. And I really believe that in the next few years, more and more people, also for private use and for business and for planning cities, will start using Earth observation. And it's not going to be just Milan or Paris, but also Baia Mare or very small villages in Romania or throughout Europe. So I believe that understanding the data also by a human factor is just as important as developing artificial intelligence. And those things will both go together. And as soon as we'll have more understanding, we'll also collaborate with sensors, with measurements, and all the data will eventually go into AI and provide us with strategies on the medium and long term.
Okay, thank you, Thorin. A very nice reflection, which I also share and well explained. It is nice that we from the space upstream to the downstream, we can do the connections. And actually, I wanted to ask, indeed, Zoltan, when you are listening to those two examples, and when you know what is going to happen with our plans for the Copernicus evolution, I understand we'll have, in the case of existing Copernicus satellites, more satellites in the orbital plane, which will improve the repeatability. Where do you think the fundamental improvements that we can expect in the next 5-10 years in the Earth observation data for city planning?
Yeah, I agree with the previous speakers. We will see a continuing explosion of data, all kinds of data types and resolutions and repeat intervals. The intervals are going to be, the observations are going to be more frequent. But I think that the real advantage becomes really obvious when you start using the satellite data with non-satellite data, with, as my colleague Beatrice said, with ground truth data, drone data, locally collected data on parameters that might not be very well measurable from space. That's when the real power of this approach is. And I really hope that we will be able to use a combination of data sources to respond to answer questions that are not just related to physical properties, but also going a bit more in the direction of, in terms of urban planning, what are the priorities for the people living in our cities? Very often we see that although a satellite-derived product is very nice and very useful, it is still not interpretable by the decision makers, and that's what we are trying to move forward. We're trying to involve, to make the link between the data and the decision makers. And I'm really happy to see today two examples from Milan and Baia Mare, where in the municipality we see people who are familiar with geospatial data, and we need more people like this to take this cause forward.
Okay, thank you very much, Sultan. We have just 1 minute left. Beatrice, any final reflection?
Yeah, I can just echo and repeat what the others have said. I think like all the things that were said so far had a very important, let's say, benefits for everyone, because first of all, a lot of companies, people, or the municipalities that were usually very distant from space technologies, because now data are for free, because now the resolution is increased, because now the latency time is less, they really see the added value in using this data, and we have really seen the number of applications blooming in this sense. On the other side, I'd also see the other fact that we don't want to over-flooding, let's say, the users, the municipalities, the decision makers with data. I think the challenge for the future is really to go from the data to the information. So try improving the processing capabilities, applying more and more artificial intelligence process to make sure that space, but also the other technologies are an aid, a tool to help the decision makers and not a burden. So we have to make sure that we easy their daily task and not to make it more and more complex.
Okay, so it's a very nice reflection. So actually, it is a very interesting thing. When we are working in space, we should never forget the user. So that's in the end what we are working for. And this connection between the applications and what we are providing, it is essential that we don't lose the connection. And that's why it's so important, our downstream applications office. And I think this has been a change of paradigm in our ESA culture, that we are now very close to the application side and working very close to the actual needs to make sure that what we are doing is helping in the right direction. That's very, very nice. So I think we are almost there. I would like really to thank I think we enjoyed the afternoon. It was, for me, very, very instructive. And I think it was nice to see colleagues from ESA and colleagues from the municipalities and the synergies we have among us. I maybe would like to ask my colleague Donatella, who is actually leading the preparation of these seminars, to provide some concluding remarks. Donatella, if you wish to maybe finish.
Thank you very much, Javier. I can echo what you are saying. I've been listening to you very attentively, having all your inputs. What is very, very nice is to see that we are all working in the same direction. There is a full link among the activities that are performed in downstream sector in ESA with the needs of our users, municipalities or others, but we are really focusing on developing our upstream to respond to the needs of the downstream. I thank the moderator, I thank the speakers, I thank all the attendees and the co-organizer who helped me, and I would like to close this session but invite you all to our next session on the 10th of December, where we are going to speak about cultural heritage. Thank you very much again, and have a good afternoon.